The 2026 RAV4 presents a paradoxical engineering achievement: supercar acceleration figures within a utility vehicle chassis. While the automotive industry bifurcates into dedicated sports platforms and dedicated haulers, the RAV4, now technically designated the RAV4 plug-in hybrid for the sixth generation, collapses these distinct categories into a singular, high-performance node. We are not merely observing a hybrid with a larger battery. We are observing a powertrain where the internal combustion engine and dual-motor electric drive operate in a state of additive rather than subtractive synergy. The result is a machine that achieves the lateral utility of a crossover while delivering longitudinal G-forces that statistically eclipse dedicated performance sedans from the previous decade. To comprehend this vehicle, one must first analyze the summation of its force vectors. The total system output has risen to a SAE-certified 324 horsepower, a significant leap over the previous generation's 302 horsepower baseline. This increase is not achieved through higher boost pressures or aggressive camshaft profiles, but through the liberalization of the high-voltage discharge rates. The 2.5-liter dynamic force internal combustion engine remains the thermal anchor, operating at a 41% thermal efficiency, but the electrical architecture has been unlocked. The front motor generator and the rear traction motor are now permitted to draw higher peak amperage from the inverter during wide-open throttle events. This is managed by a new silicon carbide semiconductor array in the power control unit, which reduces switching losses and heat generation, effectively allowing more current to reach the copper windings of the motors without triggering thermal throttling protocols. This raw power is modulated by the electronic on-demand all-wheel drive system, or AWDI. Unlike mechanical AWD systems that rely on a drive shaft and center differential to transfer torque, introducing parasitic loss and latency, the RAV4 decouples the axles. The rear wheels are driven exclusively by a dedicated, high-torque electric motor. This allows for torque vectoring reaction times measured in milliseconds. When the vehicle's yaw rate sensor detects understeer during corner entry, the system instantly increases torque to the rear axle, rotating the car into the turn. Conversely, during straight-line acceleration, the system locks the torque distribution to maximize traction. Utilizing the vehicle's weight transfer to the rear tires to put down power more effectively than a front-biased mechanical system ever could, we must then address the energy storage medium. The previous generation's 18.1 kilowatt-hour battery pack was a benchmark in energy density, but for 2026 we have achieved a substantial evolution in volumetric efficiency. By restacking the prismatic lithium-ion cells and reducing the physical footprint of the cooling modules, the engineering team has increased the total capacity to 22.7 kilowatt-hours without compromising the vehicle's interior packaging. This is not simply about adding more cells. It is about chemistry. The cathode material has been refined to increase electron mobility, reducing internal resistance. This means the battery can accept charge faster during regeneration and, crucially, discharge violently during acceleration without sustaining voltage sag. This density improvement pushes the EV-only range from a nominal 42 miles to an EPA-estimated 52 miles. Crossing the critical threshold where 90% of daily American commutes can be completed without a single rotation of the crankshaft. The physics of the 0 to 60 miles per hour acceleration curve reveals the true nature of this powertrain. The 2026 RAV4 completes this sprint in a verified 5.2 seconds. However, the raw time does not convey the sensation of the launch. In a turbocharged internal combustion vehicle, there is a delay turbo lag followed by a torque curve that builds with RPM. In the RAV4, the acceleration is digital. The electric motors deliver their peak torque at 0 RPM. The moment the accelerator pedal sensor registers voltage, the vehicle surges forward. The internal combustion engine engages seamlessly mid-launch to maintain the acceleration rate as aerodynamic drag increases. This is a hyperbolic torque curve, providing an initial impulse that pins occupants to the seat back, mimicking the launch characteristics of a pure battery electric vehicle before settling into a hybrid sustained power mode. Efficiency is not sacrificed for this performance. It is retrieved through regenerative braking coefficients. The 2026 model utilizes a new hydraulic braking booster that blends friction braking with regenerative resistance more aggressively than before. The system can now recover up to 80% of the kinetic energy normally lost to heat during deceleration. The motor generators switch polarity, becoming dynamos that resist the vehicle's momentum, converting motion back into stored chemical energy in the battery. The software calibration here is critical. It manages the handoff between regenerative braking and the physical caliper biting the rotors so smoothly that the driver cannot tactily distinguish the transition. This keeps the battery in a high state of charge, ensuring that the 300-plus horsepower is available even after prolonged periods of spirited driving. Finally, we must conduct a cost-benefit analysis against the established luxury hierarchy to achieve a similar 5.2-second 0 to 60 time in a German compact SUV, specifically looking at the BMW X3 or the Audi Q5 equivalents. One must typically option a 6-cylinder turbocharged performance variant. These vehicles command a price premium of nearly 30% over the RAV4 Prime's MSRP. Furthermore, those competitors incur high running costs due to premium fuel requirements and significantly lower city mileage. The RAV4 Prime offers a subversive value proposition. It delivers the straight-line performance of a European sports crossover, the running costs of a Prius, and the depreciation curve of a Toyota. Mathematically, it is the most logical high-performance purchase in the current automotive market, rendering the badge prestige of its competitors an expensive, irrational vanity metric.